need 2 points. In that 2 points, your selection process is in that 2 point functional value change sign means it will cut the x-axis in between 2 points x0 to x2. After that, what you are doing, you are calculating the middle point in bisection method. That middle point, suppose x2 is x0 plus x1 by 2, isn't it? And that x2 you are checking the sign along with x0 or along with x1, which is opposite, that sub interval you are considering. That was the process.
Yes, sir.
In this case, in place of x2 calculation, it is not middle value other than some other than middle point, some other point. It can be here or it can be here, no matter. It will be come by the formula of regular Folsey method, and that formula is nothing but that x2 calculation formula is this. Same thing during the class also I told you. It was there in bisection method x0 plus, sorry, this one the x1. x0 plus x1 by 2 in bisection method. But that x2 calculation will be here by this formula. x0 f of x1 minus x1 f of x0 by f of x1 minus f of x0. After getting that point, updated point in between x0 to x1, that x2 is the updated point. You will check then the functional sign along with the boundary point functional values. Suppose boundary point is x0, x0 is here, x1 is here, and you are getting x2 in between here. Suppose x2 here. So you are checking functional sign along with the lower boundary point. If it is opposite, along with the updated point functional sign, then x2 will be now upper boundary and x0 is the lower boundary unchanged. This subinterval you will pick up, another subinterval you will neglect. And you just renaming that 2 points again x0 and x1. So basically, in middle point, you are checking the functional sign along with the lower boundary point functional value. If they are opposite in sign, then your updated point will be replaced by the upper bound, means x1, and lower bound will be the x0. Otherwise, if this case is not happen, means graph is cutting another subinterval, in this subinterval not, then else condition will be satisfied. So this type of things I told you in bisection method also. So only that difference is you just see in bisection method, in place of x2, that is middle point we are considering there. Here it will be calculated by this formula. Okay. And what is the secant method? That is also I told you in last class. But for the secant method, you will use the variable like array format, in which way you have used in Newton-Raphson method, like that. But for the regular Folsey method, use the process of bisection method. Okay.
So here also we will use the do while loop. No?
Yeah, obviously you just see and watch the complete file what I have actually assigned for you. Okay. This file I have assigned you, isn't it? This file is visible there or not?
Yes, visible.
In assignment section I have assigned this file. Okay. This basically whole program I have written here. This is not for an art, this is regular Folsey method actually. This is regular Folsey method. Okay, so here is you just define initial fx, and that is your header style. In the header, when you will start the main program, void main, then you just start your main program by defining the variable which are needed within the program. Suppose for the loop you need I, or suppose lower boundary point, upper boundary point, and middle value, not middle value, updated value calculation. In that point functional values I just again rename by f0, f1, f2. and that functional value will be calculated by this function you just define at the header. So that is the header portion you just define at this step first. Then your actually point searching. 2 points you need. In between that 2 points, graph is cutting the axis. So you are considering origin is the first point, and 1 is the or -1 is the second point. And in that 2 point, you are checking the functional sign. If they are same sign, means greater than 0, both negative or both positive, then your pointer will be moving again next. If for the, and that is I told you for the largest negative root, you will move your pointers left hand side for the largest negative root. For that time your comment is x1 equals to x0 minus 1. If your program is okay giving the answer and still in this comment you are not getting the answer, means you are getting some unexpected error, then maybe root is not lying in the negative side, then you just do it positive. Your pointer will move searching origin to right hand side. Okay, after getting that 2 points, suppose for the given example you will get 2 points in these comments, and at the last you will get x0 minus 4, x1 minus 5, like that 2 points you will get from this loop. After getting these 2 points, graph is lying between -4 to -5, you just use do while loop. That interval you just cut. But you are cutting by this formula. You are finding a point in between x0 to x1, another point x2 with the help of this formula. This formula is the regular Folsey method. In that point, functional value you are calculating, that is you just storing by f2, and that x2 will be again replaced by x0 or x1 by watching the functional value in these comments. And every iterated values, in every iteration it will be print 3 things: it number of iteration, in that iteration what is the middle value or root you are getting or updated value you are getting, and in that updated point what is the functional value, that is also you are printing in every iteration. When this condition will satisfy, your loop is stop working. Means last line will be the, or in output screen you will see in last iterated line what is the result you are getting, that is the solution. That is the solution up to desired degree, means on the basis of this question it will give you up to 6 decimal plus match. That is the last, that is the solution, approximate solution up to 6 decimal plus match. Can you able to do?
Yes, sir.
Yes, sir. Doing.
Actually, it is. I think you just if you have done bisection method, I think in this method you will not get any trouble. Simply this portion is changing. That x2 calculation. Okay.
Yes, sir.
Try to do this and complete this, and you should submit your file. Okay. After once you will get the answer of this, in the next time in the same program, you just see for these 3 examples, this one, and this one. I think every solutions are positive. So you just try to use in this place, x1 will be x0 plus 1. X1 equals to x0 plus 1 for the smallest positive root. And in this, in the function places, you just change the value. What will be the function for these examples? Okay. And output you just try to match. You are getting the same type of value or not. For that time, again and again, you don't have to write that same program again and again. Simply you just write by giving note. If we will consider in the same example or same program the example, this output structure is looks like this. If I will consider this example, output structure will be looks like this. By giving the footnote like that at the last of your program. for this example. No need to write again and again your program.
Excuse me, sir. Sir, can we just not print the value of x2 outside the loop?
X outside the loop.
Sir, the solution, sir, since it will be recursively printing the outputs now.
It will printing every iterated output actually. You will see in last iteration, last lines, you will get the matching results. So within the do while loop, what is the last iterated line? That is the final answer, and that will be available by these commands. You just see.
Okay, sir. So, sir,
every iteration will be printed here. Okay.
Okay. So, sir, is it necessary to print all the iterations? Can't we just?
No necessary. You can opt these things. You can opt these things. Okay. You can cancel.
Okay.
To see the results actually in every iteration how it is matching. Actually, in this process, the last line will be the result. Initial lines are not results. In last line, you will see you will matching result, and whatever in the last iterated line, you will get the value that is the final result. On the basis of this restriction is fulfilled, it will print the last iterated line is the final result. Okay. To nicely watch this algorithm. Not algorithm, actually this is program, it is not algorithm. In step 1, you just try to write this type of things. In step 2, write this type. Actually, this is the algorithm also, but that is you have to write in simply stepwise. So in algorithm, actually that header or that portion will not be included. Simply we will just write with the step, with the help of step 2 and step 3, the process to calculate that technique.
So what will be the answer for first one?
First one, you are thinking it is root is lying between -4 to -5.
So the x0 and x1 will be -4. Okay.
Yeah.
So the equation is same as the previous day.
Previous problem.
The answer will be the same.
Obviously, answer will be same. In Newton-Raphson method, it will take less iteration. I think it will take more iteration. Its rate of convergence is little high. Actually, Newton-Raphson method,
it was actually 57 or 58 iteration.
58 iteration.
Maybe, sir. I'm not sure.
No. It will within 10 iteration you will get for any typical problems the answer. Newton-Raphson method having rate of convergence quadratic. In every iteration, in double decimal places will be matched. Suppose in third iteration you are getting 2 decimal match. In fourth iteration it will be 4 decimal match. In fifth iteration it will be 8 decimal match. So how that method will not take that much iteration? Okay, you may put within the loop maximum iteration, but you just put within the loop the condition also such that it will not calculate long times. Means you have to reduce the computational time also.
Yes, sir, got it.
But in this case, it is looks like 1.6. It's the rate of convergence. So in this case, compared to Newton-Raphson method, it will take more iteration. If it is taking in Newton-Raphson method, suppose 7 or 8 iteration, it will take suppose 10 or 12 iteration.
Sir, for x0 -4 and x1 -5, it is coming in 2 iterations. It is coming -4.28 in the first iteration, and then the second iteration it is value of function 2.91.
Why 2 point? It will not come out from -4 to -5.
Okay, sir.
Actually, whatever the work after getting the interval -4 to -5, After getting this interval, suppose this is -5 and this is -4. Whatever the work you are doing in between -5 to -4, then suppose x2 median calculation with the help of regular Foley method is here. Then you are selecting this subinterval. Again, x2 calculation with the help of this subinterval. Suppose that subinterval is middle point is here. Then subinterval will be this. Still, that is within whatever the work you are doing here. That is -5 to -4. So result will be -5 to -4.
So can I share my screen? Can you show it?
Okay, you can share. Let me just.
Okay.
Complete program style I have written. You share your screen. Two x0 x1. So initially, actually you are not searching the points actually. Simply you have taken initially x0 -4, x1 -5, isn't it?
Yes, sir. So the thing that we have done in the Newton method, so that also we have to do.
Okay, no problem. But that can be coming with the help of program also. That
Okay.
idea I have written in step 2. Okay, no problem. Let me see. So you are in that points you are calculating function in this point f3. It's okay, f0 to less than 0, then actually you after the if command you just see you have done little wrong. What is the updated point x2? In that point functional value f2. You are checking f2 along with f0. If that are less than 0, if this is less than 0, then 0 to x2 will be the selected interval. Means x2 will be the upper boundary point. X0 is unchanged. Okay, no problem. Else x2 will be the lower boundary point. X2 will be you just in above line number 33. X2 is the x0. X1 is unchanged. No problem. Okay, I plus plus. Okay. After the last you just come. Let's see. Compile this. It is taking a lot of iteration.
So I'm printing the same value. I think -4.33.
-4.331053.
So the answer is correct.
So why it is not stopping?
Stop kar do yaar manually.
No, not manually. Within the program it will be stopped.
Program.
You just give the command greater than 10 to the power -3. You just do this.
Sir, fab f2 minus fab of f1 होगा वहाँ पे.
No, f2 is functional value. Functional value looks like 0. If it is exact root, then it is exactly 0. Since it is approximate, so it is looks like 0. Then it's okay. You just do it -3.
So,
Bolo.
so we have to stay in the meeting.
Which meeting?
So the
This
class.
meeting, sir. Or
Yeah.
class.
Value of the function at, in this case it is stopping.
Yes, sir. 5 iterations only.
But why in the last root is minus is not coming here? Value of the
So
function.
here.
That is okay. You just see here minus 4.33109 after that. Why the before minus is not coming? It should come minus.
So here.
Abhijit, code
Yeah.
दिखाना एक second.
So minus 4.331039.
Okay, minus came, no problem.
Yes,
So you
sir.
may put your condition 10 to the power -4, -3 or -5. -6 is by default, I think. It is on the bit system. It is as like as if you are not giving any condition within the program. By default, C program will print anything up to 6 decimal place. That is, you know.
Yes, sir. Sir,
Like that, like that type of things it is doing. If you will take 10 to the power -6, so better try to give 10 to the power -4 or 10 to the power -5.
Sir, the last approx root is coming minus 0.00016.
That is functional value in that root. My root is -4.331053.
Okay, sir. I think it's
If this is the root, I told you if this is the in the exact root, if you will put back that exact value in the main function, it is exact 0. Since
yes,
these
sir.
are approximate, it is looks like 0. Minus 0.4 times 0 means it is looks like 0. Its absolute value looks like 0, isn't it?
Yes, sir. Got
So
it.
this program, okay, you just change. So you just manually you just pick up for different examples what will be the x0 and x1, means you just finding for another examples what will be the x0 and x1, and you just execute all that examples, and nicely you just put the output structure within your file. In that way you just try to do everybody. So you just take your time, no problem. Somebody wants to leave, no problem. We are leaving for some times.
Okay, sir.
Okay.
At what time we have to join, sir?
Okay, so same program he executed here. You see, everybody you are seeing that.
Yes, yes, it is visible.
So in which way I have written there, actually code in that way he written here. So you also try to implement that. For
Okay, sir,
another
sure.
remaining examples, just output you just put and simply this program only once, output for different by giving the notes. For this example, output this. For this example, output this. Okay.
Okay,
Okay,
sir.
sir.
Okay. So you
We have
may,
to join at 5 p.m., sir.
okay, you should contact me, okay, or if you do have any group, you should include me. Okay, I have written there my number also.
Okay, sir.
Are
I
you-
will ID. Where is your number, sir?
Here I have written just 9470562267. In the file it is written there. Okay,
The assignment.
in assignment file. Okay.
Okay, okay, sir. I will ID. Thank you, sir.
Okay.
Thank you, sir.
Try to complete, upload your file, and who having the problem you can ask. Later also, if I will not join, suppose we do have some meeting. Okay, near about 5 we do have a meeting. If I will not meet you, you should ask me your question in my number also. Okay.
Okay, sir. Okay, sir. Thank you, sir.
Okay, welcome. So we are we are, for time being, we are ending the meeting.
Okay, sir. Thank you, sir.
Okay, you just complete your assignment. Okay.